In this session, we're going to take a look at GeoGebra again, this time looking at the measuring tools. We find that at the 1, 2, 3, 4, 5, 6, 7th icon in the window or in the tool bar. The first tool that we have is our angle measuring tool. To use it, we need to have either 3 points or 2 lines. So let's take our new point tool and let's create 3 points. Notice the relative positions as I click on these 3 points. Point A, B, C. Now I'm going to go back and I'm going to use my angle measuring tool to measure angle A, B, C. We've measured the exterior angle at vertex B. There's an invisible triangle there, or an invisible angle, whichever way you want to think of it mentally. If we had wanted to get the interior angle, which probably would be more often, we would simply click in a different order. Instead of going counterclockwise, we would go clockwise. A, C, B. Now we have the interior angle. It's labeled with the Greek letter beta, and it's 60.87 degrees. As with virtually everything within GeoGebra, we have the dynamic relationship. So if we move point C, we notice that instantaneously the angles are all recalculated. Angle C, angle B. Now again, if we want angle A sides, we would do the same thing. Do we want it outside or inside? If we want it on the inside again, we would just go in a clockwise direction. So we'll go back and choose our angle measurement tool. That would be angle B, A, C, 66.77 degrees. Or we can have it on the outside as well. Angle C, A, B. Now we've got them both. And as you can see, they do add up to 360 degrees. That's our angle measuring tool. Now it works just as well if we have an actual figure to work from, such as a triangle or any polygon that we like. So let's go over to our polygon tool and let's create a polygon. Okay, we now have a quadrilateral with some large angles, some small angles. We can use our angle tool to measure those. We need 3 points or 2 lines. If we want to measure the angle at D, we can measure it by using the clockwise rotation concept. Angle E, D, G. We have an angle of 123.18 degrees. We can also measure a little bit more simply by just clicking on the 2 sides that form an angle. So let's choose side F, side G. There we have 314.74 degrees. If we go in the other direction, instead of going FG, we go in a descending. Let's go FE, FE, and this time we get the interior angle. Okay, quite easily done. And again, what makes it very powerful within GeoGebra is that everything is dynamic. We can move our angles around and we have instant recalculations. Let's back up. Actually, we should probably get a new screen here because we've got quite a bit going on. So let's go to a new window. The next tool we'll look at under the measuring tools, the angle with a given size. We'll choose our tool. Now as soon as we click a pair of points, we're asked to pick a particular size angle. The default setting is 45 degrees. Let's use that as it sits for the moment. So let's apply it. We now have an angle of 45 degrees created. Our first side is AB, and we have A prime, so that we have an angle AB, A prime, and it's 45 degrees. We can make any degrees we want, so let's try it again. Let's go with C, D, and this time let's change just the 45 here. I'm going to do this by inserting, I hope, and I'm going to delete my 45, leaving the degree symbol there. Let's put in, oh, let's say 75 degrees. Notice that we can choose counterclockwise or clockwise. This time let's choose clockwise. Okay, we now have an angle of 75 degrees, and here is C prime over here. We can move point D, and that will take us up here, but notice this time the angle remains constant. Okay, we define the angle to be 75 degrees. As we move D, point C prime has to move to accommodate the size of our angle. We can move C as well. Now D remains fixed, and again C has to accommodate by maintaining its relationship, keeping that angle at 75 degrees. Potential for a lot of lessons here in a geometry class. If you don't put in degrees, we'll try this one more time. We'll choose E, and let me just put in a 1. And when we apply it, we get 57. Let's move that a little bit out of the way so we can actually read it. We have 57.3 degrees showing up there. Otherwise than that, everything remains the same. What's happened is that because we did not put in a degree symbol, the computer and the program GeoGebra interpreted it as being a radian measure. It displayed it as 57.3 degrees, but it's actually 1 radian. And again, in another lesson, we'll take a look at how to change the way we have our units displayed. The next tool we'll take a look at, distance or length, and I think we better clear our window again, so let's do that first. Okay, we're going to use, once again, that was the distance or length tool. Now, it asks us to come up with 2 points, a segment, a polygon, or a circle. So let's just start out with a couple of points. Point A, point B. Now when we go back to our measuring tool, we click on point A, we click on point B, and we get segment AB equals 4.29. Okay, so we've found the distance between A and B. We could have had a segment there, and we would have simply said the length of AB. It would have done exactly the same thing, and of course it's interactive. As we move point A, the distance changes. Okay, again, let's go back. Let's choose our measuring tool again. Let's try a segment just to make the comparison. Here's a segment between 2 points, and let's go back and measure that segment. We can just click on the segment. We don't have to click on the 2 endpoints this time. Length is 2.76. Notice the difference in notation here. Because we had the object, and the object is object A, it simply says A is 2.76. It did not have to say segment AB because in this case we only had the 2 points visible. There was a segment there, but it was not visible, so the computer tells us it's segment AB. Down here the segment is visible, and it simply gives it to us as the length of the segment. We could have had a polygon. Okay, let's take a polygon and let's see what happens. We'll do a simple 1, 2, 3, and back to the beginning point. There is a simple triangle. We'll choose our measuring tool. Now if we click on a side of the triangle, let's see what happens. We get 2.58. We get, if I can read it, 2.65, and we get 3.56. But if we click on the interior of the triangle, we get the perimeter of the entire triangle, and that's 8.79. a little arithmetic to verify that that is true. Again, the power of the program becomes apparent when you move a single vertex. We see all the affected lengths changing. In this case, length E and or segment E and segment G change, as does the perimeter. And to finish that up, let's take a circle. So we'll draw a circle. We choose our measuring tool, and the logical conclusion here would be, there's only one thing left to do, it's going to give us our circumference, and it is 8.39. By the way, a little small aside here, when a label appears to be in the way, you can always pick it up and we'll drag it a bit and just make it a little bit more visible by changing the location. It's still going to be tied to the circle. When we move the circle, the information doesn't change a bit, but if we change the dimensions, we see that that circumference label does change. And in that same measuring group again, we'll go down to area now. Let's clean up the screen one more time with a new window. And we were going to explore area. Okay, the area item calls for a polygon, a circle, or a conic. Let's take a polygon first. We could create this several different ways. The polygon tool is the quickest way, but anything that we create as a polygon, whether it's by individual segments, by points, or by the polygon tool itself, will still obey the laws of the measurement being made. We want the area, so we just click once on the polygon, and there's the area of our polygon ABCDE. It is 20.24 square units. If we try to click on something like an individual side, nothing happens because this is an area formula and it wouldn't apply to a segment. Okay, and let's do a circle. There's a small circle. Click on our area tool, and once in the circle, our area is 1.34 this time. Again, I'm just going to drag that label down so we can see it a little bit better. And lastly, in this set of tools, we have the slope tool. Let's clear our screen a little bit one more time. Just going to click backwards here. Now, slope obviously requires a line or a line segment at least. So let's go back and choose a basic line. And now, when we come back to our measuring tool, we can come down to slope, and it asks for a line. Okay, so let's click on line A, and there is the slope, 1.15. If we click on point B, let's see if anything different happens. It duplicates the original, so that becomes unnecessary, and let's undo it. Okay, the slope has one line, the point line has one slope, no matter where we click on the line. As with everything else, the interactivity, the dynamic nature of GeoGebra shows up. If we move our line, we see instantaneously the slope is being recalculated. This opens up all kinds of possibilities for investigating relationships such as parallelism, perpendicularity, and so on in the whole field of geometry and some of the algebra connections as well. That concludes our review of some of the basic tools for measurement within GeoGebra.